Guys, the next thing we're going to look at is perpendicular lines. I would start by saying the word perpendicular means at right angles to. So if two lines are parallel, they never meet, they have the same gradient, and the only thing that is different between them or among parallel lines is the y-intercept. But when two lines are perpendicular, the two lines meet at right angles. When two lines are perpendicular, the two lines meet at right angles. Guys, the product of the gradients of perpendicular lines is -1. Guys, what is the gradient of this line? What is the gradient of this line? I'm calling it M1. What is the gradient of the line? Y is equal to -3/2 x plus 6. What is the gradient of that line? Anybody? Very good. Gradient is -3/2. What is the gradient of this line? Let me erase it from here. It's too close. So for this line, M1, the gradient is -3/2. What is the gradient M2 of this line? The gradient is 2/3. Let's multiply M1 by M2. And we're multiplying the two gradients. This is 2/3. Sorry, first M1 is -3/2 times 2/3. 2 cancels 2, 3 cancels 3. This is -1. Guys, now if you multiply the gradients of two lines and get -1, it is because the two lines are perpendicular to each other. If you multiply the gradients of two lines and get -1, it is because the two lines are perpendicular to each other. Stay with me. Guys, what is important is the implication. This is the implication. What is the implication of that statement? The implication is this: to find the gradient of all lines perpendicular to a given line, simply invert the gradient of the given line and change its sign. To find the gradient of all lines perpendicular to a given line, simply invert the gradient of the given line and change its sign. In other words, the gradient of the first line M1 is -3/2. Now, if the second line is perpendicular to the first, the gradient of the second line, to get it, I must invert the gradient of the first and change its sign. So if the gradient was -3/2, if I change the sign, it becomes positive. If I invert it, it becomes what? 2/3. Guys, the implication of the statement that the product of the gradients of perpendicular lines is -1, the implication of that statement is this: to find the gradient of all lines perpendicular to a given line, simply invert the gradient of the given line and change its sign. Stay with me. Here's a simple example. And all example 5 says is this: M1 and M2 are the gradients of two perpendicular lines. Complete the table by inserting the missing M2 values. Everybody do this, please, and then I will do it after you. You have 2 minutes. All right, so let's say this is, well, let's not say one. I, triple I, and IV. All right, Anaya, if the gradient of a line is 4/3, What would be the gradient of a line that is perpendicular to that line?
-3/4.
Very good. Minus 3/4. You must invert the gradient and change its sign. Janelle, if the gradient of a line is 3/5, what would be the gradient of a line that is perpendicular to that line? Very good. -5/3. Jadon, if the gradient of a line is -1/2, what would be the gradient of a line that is perpendicular to that line? Sorry, if it is -2, what would be the gradient of the line that is perpendicular to that line? Very good. +1/2. Guys, -2 is the same as saying -2/1. If you change the sign, it becomes positive. If you invert it, it becomes 1/2. So again, -2 is the same as saying -2/1. If you change the sign, it becomes positive. If you invert it, it becomes a half. Anaya, if the gradient of a line is -1/3, what would be the gradient of a line that is perpendicular to that line?
3.
Very good. It should be positive 3/1, which is the same as just saying 3. Very good, guys. Very good. So let us stop here.